everyone, and welcome to Sally and Bytes. Today, I am here to teach Chapter 8, Tuples in Python, Part 2, for the Class 11 students of Computer Science. In this video, we are going to discuss about tuple operations, tuple slicing, tuple concatenation, tuple replication, membership operator in and not in, comparing tuples, deleting tuples, tuple functions, packing and unpacking tuples, features, advantages and disadvantages of tuples and practical implementation. So let's dive in and get started. In Python, a tuple is an immutable sequence of elements, enclosed in parentheses. Tuples are similar to lists, but unlike lists, tuples cannot be modified once they are created. However, you can perform various operations on tuples to manipulate and access their elements. Here are some common tuple operations in Python. Tuple slicing, tuple concatenation, tuple replication, membership operators. Let's see one by one in detail. Tuple slicing is a technique used to extract a portion of a tuple by specifying a range of indices. It allows you to create a new tuple that contains a subset of elements from the original tuple. A slice of a tuple is basically its subtuple. In Python, tuple slicing is done using the square bracket notation. Here's the syntax for tuple slicing. Tuple underscore name of open square brackets, start, stop, step, close square brackets. Here, start is the starting point. Stop is the stopping point, which is excluded. Step is the step size, also known as stride. Some key points to remember. If start value is not given, slice starts from index 0. If stop value is not given, it will take it to the end. If step value is not given, default value is taken as 1. It includes the first element, but excludes the last element. The first value in a tuple is at index 0. You can use the index values in combination with square brackets to access items in a tuple. Now, look at the picture, how tuple slicing is done. Tuple slicing is a technique used to extract a portion of a tuple by specifying a range of indices. It allows you to create a new tuple that contains a subset of elements from the original tuple. In this picture, if we consider the positive index, that is forward indexing, index 3, 4, 5 are sliced and a new tuple with elements 40, 50 and 60 are formed. If we consider the negative index of step 1, that is backward indexing, it means to increment the index every time by -1, meaning it will traverse the list by going backwards. Now look at the negative index. Index -5, -6, -7 are sliced and a new tuple with elements 60, 50 and 40 are formed in backward direction. Let's see some examples. Example 1. A tuple with elements of different data types are given. Now look at the top picture. Here, I have marked the positive indexing and negative indexing for this tuple. In positive indexing means forward direction, look at the green arrow in forward direction, and follow with me. Index 0 holds a string apple, index 1 holds the integer value 1, index 2 holds a list holding elements 2, 3, 4. Index 3 holds a nested tuple containing 2 strings banana and orange. Index 4 holds a float value 5.5. Now, let's learn the negative indexing that means backward direction. Look at the red arrow in backward direction and follow with me. Index -1 holds the value 5.5, index -2 holds the nested tuple holding 2 strings banana and orange, index -3 holds the list containing 3 elements 2, 3, and 4, index -4 holds the integer value 1, and index -5 holds the string apple. Now, look at example 1, second line. We use tuple slicing to extract a slice from index 2 to index 3, exclusive. The slice, 2:3, includes the element at index 2 but excludes the element at index 3. Since slicing returns a new tuple, the resulting slice is printed as a tuple containing the list 2, 3, 4. I have given a detailed explanation below. Just pause the video and recall the start, stop and step value, with the above indexing picture of the tuple given. Now we can work out more examples with the same tuple given. Example 1. Here, we extract a slice from index 1 to index 2, exclusive, using tuple slicing. Now, look at the positive indexing in the picture. That is forward direction. The slice, 1:2, includes the element at index 1 but excludes the element at index 2. Thus, the resulting slice is printed as a tuple containing the integer 1. You can check the output on the console. Now, look at example 2. In this example, we utilize negative indices to slice the tuple. Now look at the negative index on the above picture, that is backward direction. The slice, -5:-3, starts from the element at the 5th position from the end, inclusive, and ends at the element at the 3rd position from the end, exclusive. Therefore, the resulting slice is printed as a tuple containing the string apple and the integer 1. Now look at example 3. The slice tup1 of -8:-6. In the example, the index given are out of range and result in an empty tuple. Example 4, given below. Print tup1 of -3:-5:-1. The output will be a tuple holding the list 2, 3, 4, and the integer value 1. This will output a slice of the tuple tup1 starting from the index -3 and ending at the index -5, exclusive, with a step of -1. The result will be a new tuple with the elements the list 2, 3, 4, and the integer value 1, printed in reverse order. You can check the above picture for reference. Let's see some mode examples. Example 1. In this step, we use tuple slicing to extract a slice from index 0 to index 10 exclusive, with a step of 2. Now, look at the picture. The slice 0:10:2 includes elements starting from index 0 and up to index 10 exclusive, in steps of 2. Thus, the resulting slice is printed as a tuple containing the element 5 at index 0, element 15 at index 2, element 25 at index 4, element 35 at index 6, and element 45 at index 8. You can check the output on the console. Now look at example 2. Here, we extract a slice from index 1 to index 10 exclusive, with a step of 3. Now look at the second picture. The slice, 1:10:3, includes elements starting from index 1 and up to index 10 exclusive, in steps of 3. Therefore, the resulting slice is printed as a tuple containing the element 10 at index 1, element 25 at index 4, and element 40 at index 7. You can check the output on the console. Example 3. In this example, we use tuple slicing with a step of 3 to extract elements from the beginning to the end of the tuple. Now, look at the picture. The slice, 3, includes elements starting from index 0 and up to the end of the tuple in steps of 3. Hence, the resulting slice is printed as a tuple containing the element 5 at indices 0, element 20 at index 3, and element 35 at index 6. You can check the output on the console. Now, look at example 4. In this example, we use tuple slicing with a step of 2 to extract elements from index 4 to the end of the tuple. Now, look at the second picture. The slice, for :2, includes elements starting from index 4 and up to the end of the tuple in steps of 2. Therefore, the resulting slice is printed as a tuple containing the element 25 at index 4, element 35 at index 6, and element 45 at index 8. You can check the output on the console. Let's learn about tuple concatenation. tuples can be concatenated or joined using the plus operator. For example, tuple 1 plus tuple 2 creates a new tuple by combining elements from tuple 1 and tuple 2. In Python, tuples are immutable, which means they cannot be modified once created. Therefore, when you want to concatenate tuples, you create a new tuple that contains the elements of the original tuples. Now, let's see an example. Example 1. Tuple 1 contains the elements 1, 2, 3, and tuple 2 contains the elements 4, 5, 6. The line concatenated underscore tuple equals tuple 1 plus tuple 2 performs tuple concatenation. It uses the plus operator to combine the elements of tuple 1 and tuple 2 into a new tuple called concatenated underscore tuple. So the output printed is a new tuple holding elements 1, 2, 3, 4, 5, 6. Let's work out some more examples. Example 1. Variable tuple 1 holds the elements 10, 20, 30, 40. The second line, print tuple 1 of 1:3 plus 50, 60. This line retrieves a slice of tuple 1 from index 1 to index 3, exclusive, which returns 20, 30. You can check the above picture for reference. Then, it concatenates, that is joins this slice 20, 30 with the tuple 50, 60 using the plus operator. The resulting tuple is printed as 20, 30, 50, 60. You can check the output on the console. Example 2. Print tuple 1 of 1:3 plus a tuple 1 of 0, This code retrieves the slice 20, 30 from tuple 1 and concatenates it with a tuple holding tuple 1 of 0, Here, tuple 1 of 0, creates a tuple with a single element, which is the first element of tuple 1 of 10. The resulting tuple is printed as 20, 30, 10, which is outputted on the console. Example 3. Print tuple 1 of 1:3 plus tuple 1 of 0. In this example, the code attempts to concatenate the slice 20, 30 with tuple 1 of 0, which is the first element of tuple 1 of 10. However, there is an error in the code. The plus operator for concatenation expects a tuple on both sides. When you use tuple 1 of 0, it is a single element, integer, not a tuple. So, it results in type error. Let's learn about tuple replication. To replicate a tuple in Python, you can use the multiplication operator, asterisk. Let's see some examples. Example 1. We define a tuple my_tuple containing the elements 1, 2, 3. We create a new tuple replicated underscore tuple by multiplying my_tuple by 3. This replicates the elements of my_tuple 3 times. We print the replicated underscore tuple, which outputs 1, 2, 3, 1, 2, 3, 1, 2, 3. Example 2. We define a tuple my_tuple containing the element hello, Note that the comma after the element is necessary to indicate that it is a tuple. We create a new tuple replicated underscore tuple by multiplying my_tuple by 3. This replicates the element of my_tuple 3 times. We print the replicated underscore tuple, which outputs hello, hello, hello. Example 3. We define a tuple my_tuple containing the elements 1, 2, 3, 4. We access a slice of my_tuple using the indices 1 and 3, exclusive. This returns a new tuple containing the elements 2, 3. We multiply the sliced tuple by 3, replicating the elements 2, 3, 3 times. We print the replicated tuple, which outputs 2, 3, 2, 3, 2, 3. Note that in all the 3 examples, the original tuples are not modified, and the multiplication operator creates new tuples or strings with the replicated content. Also remember, asterisk operator requires a tuple and an integer as operands. Let's discuss about the membership operators in and not in. In Python, the membership operators in and not in can be used to check if an element is present or not present in a tuple. These operators return a Boolean value indicating the result of the membership test. Let's see some examples. Example 1. In this example, we have a tuple called fruits containing 3 elements, apple, banana, and orange. We use the in operator to check if apple is present in the fruits tuple, and it returns true because apple is indeed present. Example 2, when we check for grapes, which is not in the fruits tuple, the in operator returns false. Example 3. Similarly, we use the not in operator to check if apple is not present in the fruits tuple, and it returns false because apple is present. Example 4, when we check for grapes, which is not in the fruits tuple, the not in operator returns true. The in and not in operators can be used with tuples, lists, sets, and other iterable objects in Python to perform membership tests. Tuples in Python support several built-in functions that can be used to perform various operations. Here are some commonly used built-in functions that work with tuples: len, count, any, min, max, sum, sorted, index. Let's see one by one in detail. Len function returns the length or the number of elements in a tuple. It counts the total number of elements in a tuple. Let's see some examples. Example 1. The tuple tup1 contains 6 elements, so the len function returns 6. Example 2. The tuple tup1 contains 5 elements, including a nested tuple. The len function counts the nested tuple as a single element, so it returns 5. Example 3. The tuple tup1 contains 4 elements, including an integer, a string, a float, and a list. The len function returns 4. The count function returns the number of occurrences of a specified element within the data type. Let's see some examples. Example 1. In this example, the count function is used to find the number of occurrences of the element 2 in the my_tuple. The function returns 3 because 2 appears 3 times in the tuple. Example 2. Here, the count function is used to count the occurrences of a specific tuple, 1, 2. In this example, the count is indeed 3 because tuple, 1, 2, appears 3 times in my_tuple. In Python, the any function is a built-in function that can be used with various data types, including tuples. The any function returns true if at least one element in the iterable is considered true, and false otherwise. Example 1. In this example, the any function is applied to the tuple my_tuple. The elements of my_tuple include 0, empty space, false, an empty list, and none. Since all of these values are considered as falsy in Python, the any function returns false. Example 2. In this example, the tuple my_tuple contains an additional element, 42, which is considered as truthy. As a result, the any function returns true. You can use the any function with tuples or any other iterable to check if any element evaluates to true. If at least one element is true, any returns true. If all elements are false or falsy, it returns false. Let's learn about the min and max function in tuple. Min function shall return the element with minimum value from the tuple. Max function shall return the element with maximum value of the tuple. To use the min and max function, all values in the tuple must be of same type. Let's see some examples. Example 1. The first line creates a tuple called my_tuple with elements 5, 3, 8, 2, 1. It consists of numeric values. The next line uses the min function to find the minimum value from the my_tuple. The smallest value in the tuple is 1, so minimum is assigned the value 1. The following line prints the message the minimum value is 1, using the print function to display the minimum value. Example 2. Next, the code uses the max function to find the maximum value from the my_tuple, tuple. The largest value in the tuple is 8, so maximum is assigned the value 8. The subsequent line prints the message the maximum value is 8, displaying the maximum value. Example 3. The code reassigns my_tuple with a new tuple, 5s8 byte 1, that contains both numeric and string values. When attempting to find the minimum value of this new tuple, which includes mixed data types, type error may occur because all values in the tuple must be of same type. You can check the outputs displayed on the console. In Python, the built-in sum function can be used to calculate the sum of elements in a tuple. However, the elements in the tuple must be numeric for the sum function to work properly. Now, look at the example. In this code, the sum function is called with the my_tuple as the argument, which calculates the sum of all the elements in the tuple. The result is stored in the total variable and then printed to the console. Note that if any of the elements in the tuple are not numeric, you will encounter a type error. Sorted is used to sort the elements of a tuple. It returns a list after sorting. Example 1. In this example, we start with a tuple called my_tuple with elements 5, 3, 8, 2, 1. Next, we use the sorted function to sort the elements of my_tuple. Since the sorted function returns a new list containing the sorted elements, we assign the result to the variable sorted_tuple. After that, we use the print function to display the sorted tuple. The output will be sorted tuple 1, 2, 3, 5, 8. The sorted elements are enclosed in square brackets because the sorted function returns a list. You can check the output on the console. Example 2. Here, we continue with the previously defined my_tuple, tuple. We apply the sorted function to my_tuple, which returns a sorted list. To convert the sorted list back to a tuple, we use the tuple function. The result is assigned to the variable sorted_tuple. Finally, we use the print function again to display the sorted tuple. The output will be the same as before. Sorted tuple 1, 2, 3, 5, 8. This time, the sorted elements are enclosed in parentheses, that is round brackets, because the tuple function converts the list to a tuple. You can check the output on the console. The index function in Python is used to find the index of a specific value within a tuple. The syntax is tuple.index of value :start :end. Here, start and end are two optional parameters for the start and end of the tuple's index. Let's see some examples. Example 1. In this example, a tuple named tuple is defined with the elements right, wrong, right, wrong, right, wrong. The index function is then called on tuple with the argument right. This will return the index of the first occurrence of the value right in the tuple. The output will be 0. Since right appears at index position 0, the output is 0. I have highlighted right in yellow color. So accordingly, you can check the index 0, given on the above box. Example 2. Here, the index function is called on tuple with the argument wrong. It returns the index of the first occurrence of the value wrong in the tuple. The output will be 1. Since wrong appears at index position 1, the output is 1. I have highlighted wrong in yellow color. So accordingly, you can check the index 1, given on the above box. Example 3. In this example, the index function is called on tuple with two arguments, right and 1. This means that the search for the value right will start from index position 1 onwards. It will return the index of the first occurrence of right after index 1. The output will be 2. Since the first occurrence of right after index 1 is at position 2, the output is 2. I have highlighted the right in yellow color. So accordingly, you can check the index 2 given on the above box. Example 4. The index function is called on tuple with wrong and 2 as arguments. This means that the search for the value wrong will start from index position 2 onwards. It will return the index of the first occurrence of wrong after index 2. The output will be 3. Since the first occurrence of wrong after index 2 is at position 3, the output is 3. I have highlighted the wrong in yellow color. So accordingly, you can check the index 3 given on the above box. Example 5. In this example, the index function is called on tuple with 3 arguments, right, 1, and 4. This specifies a search for the value right between index positions 1 and 4, exclusive of 4. It will return the index of the first occurrence of right within this range. The output will be 2. Since the first occurrence of right within the specified range is at position 2, the output is 2. I have highlighted the right in yellow color. So accordingly, you can check the index 2 given on the above box. Example 6. Here, the index function is called on tuple with the argument yes. However, since yes is not present in the tuple, a value error will be raised. To compare tuples in Python, you can use the comparison operators, less than equal to, greater than equal to, not equal to, just like you would with other data types. Tuples are compared element-wise, starting from the first element. If they are equal, it goes on to the next element, and so on, until it finds elements that differ. Let's see some examples. Example 1. The first line defines tup1 as a tuple containing the elements 10, 20, 30, and the second line defines tup2 as a tuple containing the elements 40, 50, 60. The line print, tup1 greater than tup2, compares tup1 and tup2 using the greater than operator. Since the first element of tup1 is 10 and the first element of tup2 is 40, the comparison stops there, and the result is false. Therefore, the output will be false. Example 2. The line print, tup1 not equal to tup2, compares tup1 and tup2 using the not equal operator. Since at least one element in tup1 is not equal to the corresponding element in tup2, which is true for all elements, the result is true. Therefore, the output will be true. Example 3. Here, tup1 is a tuple of integers, 10, 20 and 30, and tup2 is a tuple of floats, 10.0, 20.0, 30.0. In Python, when comparing tuples, elements are compared based on their values and types. However, when comparing an integer with a float, Python considers them the same as long as their values are equal. In this case, all elements in tup1 and tup2 have the same values, although their types differ. So, the comparison tup1 equal to tup2 will evaluate to true. Therefore, the output will be true. In Python, tuples are immutable, meaning their elements cannot be modified once created. However, you can delete an entire tuple using the del keyword. Let's see some examples. Example 1. Tuple named my_tuple holds the value 100, 200, 300 and printed. Output displayed is 100, 200, 300. Next, the del keyword is used to delete the my_tuple. After deleting the tuple, attempting to print it will raise a name error since the variable no longer exists. It's important to note that once a tuple is deleted, you cannot access or use it anymore. If you need a data structure that allows modifications, consider using a list instead of a tuple. Packing and unpacking are two operations related to tuples in Python. Packing a tuple. Packing refers to creating a tuple by grouping multiple values together. You can pack values into a tuple by simply separating them with commas and enclosing them in parentheses. Example of tuple packing. In this example, the values 1, 2, and 3 are packed into a tuple called my_tuple without explicitly using parentheses. Python automatically recognizes the comma-separated values as a tuple. Unpacking a tuple. Unpacking is the process of extracting individual elements from a tuple and assigning them to separate variables. It allows you to conveniently access and work with the elements of a tuple. In this example, the tuple my_tuple is unpacked, and its elements are assigned to the variables a, b, and c. Each variable receives the corresponding value from the tuple. Packing and unpacking are complementary operations that allow you to easily group values into a tuple or extract values from a tuple into separate variables. Features of Python. Immutable. Tuples are immutable, meaning their elements cannot be modified or reassigned after creation. However, you can create a new tuple by concatenating or slicing existing tuples. There is no append or extend methods for tuples. You can't remove elements from a tuple. Tuples have no remove or pop method. Heterogeneous data. Tuples can contain elements of different data types, such as integers, floats, strings, or even other tuples. This allows you to group related data together. Iterable. Tuples are iterable, which means you can use them in loops or apply iteration-related functions, like for loops, in operator, len, and tuple function. Arbitrary length. Tuples can have any number of elements, including 0 elements, an empty tuple. Ordered. The elements in a tuple have a defined order, and this order is preserved when accessing or iterating over the tuple. You can access individual elements using indexing or slicing. Packing and unpacking. To change a tuple, you can unpack it first, then change the value and pack it again. Advantages of tuples. Immutable. Tuples are immutable, meaning their elements cannot be modified after creation. This immutability guarantees the integrity of the data, making tuples useful for storing values that should not be changed accidentally. Order and indexing. Tuples preserve the order of their elements, allowing for easy indexing and retrieval of specific values by their positions. Heterogeneous data. Tuples can contain elements of different data types, making them versatile for grouping related data together, such as coordinates, database records, or function return values. Memory efficiency. Tuples are more memory efficient than lists because they are immutable. This immutability allows for better memory optimization and faster operations. Hashable. Tuples are hashable, making them suitable for use as keys in dictionaries or elements in sets. The ability to hash tuples allows for efficient data lookup and manipulation. Disadvantages of tuple. Immutability. While immutability can be an advantage, it also means that you cannot modify, add, or remove elements from a tuple once it is created. To make changes, you need to create a new tuple, which can be less efficient when dealing with large data sets. Limited functionality. Tuples lack some of the functionality provided by other data structures, such as lists. For example, you cannot append or extend a tuple directly. Instead, you need to create a new tuple with the desired values. Less flexible. Tuples do not provide the flexibility of dynamically modifying their elements. If you need a data structure that can be modified during program execution, a list may be more suitable. Lack of named elements. Unlike dictionaries, tuples do not have named elements. Accessing values in a tuple relies on positional indexing, which can make the code less readable if the positions are not self-explanatory. Thanks for watching. Watch the upcoming videos. Chapter 8, Dictionary in Python, Part 1. Creating a dictionary, methods to create a dictionary, accessing elements in a dictionary, traversing a dictionary, appending values to a dictionary, updating elements in a dictionary, removing an item from dictionary, membership operator in dictionary, and practical implementation. You can check the link in the description box below.